Hi class, I hope you had a great weekend and this is the last lecture. You have a test tomorrow. If you have any questions, just email me. Otherwise, make sure you do all my assignments and watch this video as well as Friday's video so that you can get the knowledge for the test. If you haven't already picked up a standard prep sheet, make sure you do that today or print one off on your own time. It's linked on the calendar. I'm not there today, but Miss Eichten can get you a copy from my room or let you in my room. They're on my desk. They're yellow. I will see you tomorrow. Here we go. Today we're going to quickly learn about mutations. So we'll start with what is a mutation. A mutation is any change in the order or sequence of bases in DNA. There are three types of mutations. Mutations can be beneficial, or not types, but three ways mutations can affect your body. They can be beneficial, so this is a mutation that's going to be good for you. An example is they just found a gene or a mutation some people have that allow them to be very good at music. Mutations can also be neutral. This is where the mutation gives you no reproductive benefit or no reproductive harm. So a mutation that gives you longer toes would be one. This isn't going to harm you or help you in any way. Third, there's a harmful mutation. So this is a mutation that we often think about, a kind of mutation that hurts you. And an example of that would be a mutation that would give you a heart defect. So what causes mutations? There are two categories of things. On this side, I have radiation, for example, from the sun or from X-ray machines, pollution, random DNA mutations, and then genetics. On this side in purple, I have radiation as well from the sun, smoking, drinking, and carcinogens, which are things that cause cancer, chemicals that cause cancer. For example, cigarettes have a lot of carcinogens in them. There's also a lot of products that you can be used. I know there's a big lawsuit right now going on about Roundup, carcinogens in Roundup, the stuff you spray on your grass. So a lot of outdoor products have carcinogens, or inside household cleaning products have carcinogens in them as well. I have them grouped into two groups because there are two main things that cause cancer. Hopefully you've been able to try to guess what they are, so you might want to pause and see if you can figure out what they are. But on this side, I have environmental factors. So radiation, pollution, random DNA mutations, genetics. You don't really have control over this stuff. Excuse me. And then on this side, I have personal health choices. So radiation I have on both sides because you may just get radiation from being out in the sun all day due to your job or just being in the sun, skin cancer, etc. Over here, you might choose to go to tanning places or lay out in the sun every day in the summer. So it could be both environmental factor and a personal health choice. Smoking, drinking, carcinogens, all personal health choices. There are three types of DNA mutations you need to know. The first one is substitution. Substitution is where one DNA base is switched for another. So if the original DNA read ATT, GCG, CCA, ATA, CGG, ATC, after a substitution mutation, you might have ATG, GCG, and so on. You see here that one DNA T, base T, is switched with a G. That would be a substitution. The second type is a deletion. A deletion is where one DNA base is deleted and the rest is moved over to fill the empty space. So same thing, if our DNA before was that same ATT, GCG, CCA, ATA, CGG, ATC, Afterwards, you might have something like this. So here I've removed this second T, A-T-T. I've removed that T, and everything else scooches down. Oops. This can be hard to see because as it scooches down, here where I have this question mark, a new letter would be moved. Our DNA is lots of bases long, and so if we lose a base, we don't simply see one less base, we'll actually see a new letter move down here. So what you're looking for is the whole sequence to be the same, just shifted one to the left. So instead of the G being here, now the G is here, the C is here, the G is here, C, A, etc. The last type of mutation is an addition, where one DNA base is added and the rest are moved over by the addition. So if the DNA before the mutation is ATT, GCG, CCA, ATA, CGG, and ATC, afterwards you would see something like this. So here I've added a letter C, and now everything has been shifted this way by the addition. Okay, the last thing you need to know are the cancer checkpoints. So this is a cell cycle. You should be able to fill this out yourself at this point with the exception of the purple and the blue pieces. So once again, we have G1, which is where the cell grows a little bit and does its normal job. We have S that comes next, which is where the cell does DNA replication. We have G2 that comes after that, which is where the cell grows more and gets ready to divide. We have mitosis, which is where the nucleus divides. Cytokinesis, where the cytoplasm divides. There's 3 places during this cell cycle where your cell stops and checks to make sure there's nothing wrong with it. So the G1 checkpoint happens at the end of G1. At this checkpoint, your body stops your cell from growing, and it says, is the cell big enough? If the cell is big enough, it gets to go on to S. If it's not big enough, it has to stay in G1 and keep growing. DNA replication happens, there is no checkpoint, G2 happens, and the cell grows. There is a checkpoint then at the end of G2. And at the end of G2, it checks if your DNA has been copied correctly. Now, the DNA has been copied way back here in replication, but it doesn't get checked until G2. If the DNA has not been copied correctly, so if you have one of these 3 types of mutations going on, what happens is something called apoptosis, which is cell suicide. So the cell will kill itself. Last, at the beginning of mitosis, there's an M checkpoint, and this checks to see if all the parts of the cell are ready to divide. So, do you have 2 sets of mitochondria? Do you have 2 sets of chloroplasts? Are all the chromosomes lined up at the middle? Is everything ready to divide? If everything's ready to divide, this checkpoint gets okayed and the cell moves through the rest. Now, when these don't work, we get cancer. So cancer is when one or more of the checkpoints are broken, so the cell divides quickly and out of control. When you get cancer, you often get a tumor. It's one of the first signs that you have cancer. And what's happening is that the cell is dividing really quickly, and as a result, you get this big lump of cells that don't have any function. They're not doing their right things. They're simply dividing and taking up space that should be being used for, let's say you have cancer in your liver, they should be being used as liver cells, but now they're taken up with these dysfunctional cancer cells. Another thing that makes cancer so deadly is that cancer cells can live forever. So most of your cells, as their DNA replicates over and over again, the DNA gets older and older, and the DNA starts getting old enough where eventually it's going to wear out, and your cell will get rid of it because the cell's lifespan is up. In cancer cells, however, they fix themselves. So if you watched the Henrietta Lacks video before watching me, cancer cells live forever. Henrietta Lacks' cells are still alive today, and the reason is they can repair their DNA and make their DNA brand new so that they're like brand new cells. And thanks for watching. I really appreciate it, you guys. And let me know if you have any questions, and good luck tomorrow.